What do you see on the screen? I just want to ensure you see the right screen. Quickly put chapter 16. Fantastic. Okay, fine. So let me quickly recap what we have in chapter 16. We have gone through FMEA revisions. We've gone through control plans, visual management, SPC charts, and stuff like that, which is the IMR chart, and I'll go to the Xbar R chart. Okay, focus on the IMR chart and Xbar R chart. Okay, in the IMR chart, if you see here, you see that this data point is come outside the limit. So this means something has happened, and we know that it's special cause, and individual values are plotted here. And the ranges are plotted like this. If you see here on the left side, the difference between these two numbers is 2.2 and 2.2 is plotted here. Okay, all positive. Okay, you just find the difference and take the modulus and plot here. This is called range charts. And when the range is out of control limit, there is a control limit for the range also. If the range is out of control also, it means there is a special cause. That's all that you need to remember here. Okay, again, these charts are plotted by softwares, so don't need to worry. But here I just wanted to help you understand. Suppose if I give you the data of like this 2.38, 2.06 and stuff like that, let us put this and see for your understanding how is the range calculated. 2.38 minus 2.06 is 0.32, and if you see data point 2 and 3, 2.06 and 2.46, the difference is 0.4. So all these differences are put. These differences is called as a range. Okay, and the moving range is nothing but the average of these ranges. Right, the average of this range, and then there is an upper control limit for that. Okay, and finally all this is plotted here. This is just to quickly help you understand how it is plotted. Don't worry about that. You need to take the hard work of plotting this. If you put the data and click the software like Minitab or SPSS or JMP or Data Tab, there are a lot of softwares. It will give you the chart. It will also give the interpretation of the chart. But you need to understand fundamentally how these are plotted, and that's the reason I've showed with the data tables and this. Okay, all right, so data can be represented like this, before and after, and when you present to the management, you can always show, okay, before it was like this, after it is like this, and the individual moving range chart will give you a nice representation to showcase to the management on what has happened before and what has happened afterwards. Okay, and this is a typical output from the Minitab software. And don't get overwhelmed by all this graph. All that you have to understand here is the graph will show the variation of this data. You can also see and interpret this data. And you can also see the red spot that it is highlighting to you that there is a special cause. You need to find out what has happened in the process during this time. And the software will also guide you what to do. Okay, now the question and answer session. Quick, how many of you are ready for the question and answer session? Type ready in the chat box. Okay, all of you ready? Good. So when should you use an IMR, individual moving range chart, instead of Xbar R chart? When the sample size is greater than 10, when the data is collected in subgroups, when only one measurement is available for per time period, and when the data follows a binomial distribution. Let's quickly see the answer in the chat box. That's right. C is the right answer. Good. When only one measurement is available for the time period. Fantastic. One more question on this. What is the primary purpose of a moving range? To monitor the mean of the process, to track the variation between consecutive individual data points, to calculate the median of the process, to compare the process variation over a long period of time. Let me quickly see the answers in the chat box. This is the B is the right answer, to track the variation of the individual data. Okay, now that you have understood this IMR, let us quickly complete the Xbar R chart also today. Okay, suppose if you have this subgroups and help you understand what is subgrouping here. So what do you see on the screen? Let's see what do you see on the screen. Type in the chat box quickly. What do you see on the screen? All right, water bottles manufacturing. Okay, you see a water bottle manufacturing. Now, imagine that this is a costly liquid that is you are the thing. I'm saying costly liquid because you want to make sure that you don't fill more, you don't fill less, because it's quite expensive. You don't want to waste. So subgrouping is nothing but you cannot measure each and every bottle and take action. There are millions of pieces that will come out. So you take what is called as a sample. Okay, when you take a sample for a particular time or a particular period, some few quantity, it is called a subgrouping. All right. Now, so those subgroups will have within that group, suppose if you take at 1 o'clock 5 bottles, there will be a variation within those 5 bottles. That is called within variation. Okay. If within is clear, all of you type within in the chat box. That is called within variation. This is what you want to understand in Xbar R chart. Okay, there is something called as within variation. Suppose if I take 5 bottles at 1 o'clock, 5 bottles at 2 o'clock, 5 bottles at 3 o'clock, 5 bottles at 4 o'clock, and so on and so forth. Now, this 5 bottles which I take at 1 o'clock, it will have a within variation. The 5 bottles which I take at 2 o'clock will have a within variation. Now, between 1 o'clock and 2 o'clock, between 1 o'clock and 5 o'clock, there will be a variation. Yes or no? All of you type yes in the chat box. Okay. Between the things at 1 o'clock and 5 o'clock, there will be a variation. That is called between variation. All of you type between in the chat box. This is what I wanted to complete. This is the important thing in the Xbar R chart. Okay. The Xbar chart will tell you okay, the Xbar R chart will tell you the range chart shows maximum minimum values and particularly shows within subgroup variation. Whereas if you see the Xbar R chart, it shows both between and within variation. Now, this is not easy to comprehend for many people. Whoever can comprehend this, give me a 9 or 10 on a scale of 1 to 10 so that I at least know some of you have comprehended what I said. Okay, great. A few of you have comprehended, a lot of you will comprehend it. My inspiration to others is if you don't understand this, do not worry. Okay, if you have a class of people, okay, in one class you will have within the class there will be variation. If there is a different college, different students, between those colleges there will be variation. That much you remember, that is more than enough. Okay, all right, super clear. That's it. Okay, the reason that I said it, this concept is very, very important. Now, I'm not going to explain some formula behind this. Okay, how do you calculate the control limit in IMR charts? These formulas, it is just for academic interest. There are a lot of softwares which will automatically calculate it, but just take a screenshot of this. Just know that there is a formula behind calculating this. Okay, and Minitab will automatically do everything for you. You have the data. Minitab will use this formula and plot nicely in this. So you need not have to worry about, take the pain of trying to find out how it is calculated. Just know that there are the formulas behind that. Okay, if somebody wants to do a PhD in mathematics, you can go ahead and research that. Now, how are these formulas calculated? Now, I said sample group. You can take 5 bottles, you can take 10 bottles, okay, and stuff like that. So depending upon the subgroup size, whether it is 2 or 3 or 4 or 5 or 6 or 7 or 8, there is some constant that is there. And using those constants, there are some formulas that is there. What is this X double bar? X double bar is at 1 o'clock, you take 5 pieces. There is an average of 5 pieces. At 2 o'clock, you take 5 pieces. There is an average of 5 pieces. At 3 o'clock, you take 5 pieces. There is an average of 5 pieces. Now, you have one data point of average on 1 o'clock. You have one data point of average at 2 o'clock. You have one data point of average at 3 o'clock. And each of these data points, if you have 100 averages like this, average of average is called as X double bar. X bar is average. X double bar is average of average. Okay, now, again, I don't expect many of you to understand this. Those of you who have understood this on a scale of 1 to 10, please give me a 9 or 10 if it is super, super clear. All right. Okay. Now let us have some questions here quickly. The question here is, in the Xbar R chart, what does the range chart help to monitor? Does the range chart help to monitor the overall mean of the process, variation within subgroups, difference between highest and lowest value of the entire data set, or the proportion of defective items in the process? What's the correct answer in your opinion? All right, it looks like people are going more closer towards B. Okay, so the variation within subgroups is what is range. So this is an in-depth question. Okay, now let's focus on the next question here. Okay, the next question is, what is the key assumption while using the Xbar R chart? Okay, the data should be collected 1 point at a time. The sample size must always be 1. The process data should be in subgroups of equal size, typically 2 to 9. And the process should have only common causes. Don't get overwhelmed by this question. Think carefully and give me an answer. What is the key assumption? Okay, I think I apologize for the copy paste mistake. It is actually C is the right answer. Okay, I'll change it to C. Let me quickly change it here. All right, that's there. Okay, thank you. Don't get overwhelmed, some of you who are new, just be with the subject. I'll make sure that the life is interesting to you. But then just coming to one session and getting scared is not a good way to learn. Okay. So what you keep, when you encounter fear, the power of fear disappears. How many of you agree with me? Just type agree in the chat box. When you face the fear, then the fear loses its power. When you face the fear, okay, that's the best way to learn in life. I always do this. Okay, that's why if you see here, I've done B in mechanical, MSc in mathematics, MTech in technological operations, MBA in finance, MBA in marketing. I've done a PhD in lean methodology. I'm a certified NLP practitioner. I'm a certified EFT practitioner. I'm a certified Bash flower therapist, and I'm still enrolling into programs from Harvard. I'm learning strategic management and etc. The reason is, if you're passionate about something, don't be afraid. It might scare you because you're moving out of the comfort zone. Coming out of the comfort zone is always uncomfortable. You will go into fear zone. But if you go over the fear zone, then you will go into the learning zone, which is important. And when you go into the learning zone, from there, you go to the growth zone. But when you come out of the comfort zone, in the fear zone, you have to decide whether you have to come back to the comfort zone or you go back to the learning zone. That's a decision you'll have to take. From comfort, all of you type C, from C to F, from F to L, from L to G. Okay, from L to G. So comfort, fear, learning, growth. Now, in the fear zone, you'll have to take a decision. You can go back to the comfort zone or you can go back to the learning zone. People who come back to the comfort zone give excuses. People who go back to the learning zone go to the growth zone and give results. You can either have excuses, you can either have results, you cannot have both. If this is inspiring to you, if you like this, give me a thumbs up. And I want everybody to cross this fear zone, go to the learning zone so that you can ultimately end up in the growth zone. I want each and every one of you to go to the growth zone. And that's why I inspire everybody to become lifelong learners. Okay, which of the following situations would make an Xbar R chart inappropriate for use? A manufacturing where measurements are taken in batches of 5, hospital monitoring daily patient temperature. This is just a so some sort of applying your mind. Okay. Yes, hospital monitoring the daily patients is good for everyone who done, right? So whoever will want to go to the growth zone, please come to my upcoming webinar, register here, come to my upcoming webinar, graduate yourself, okay? Okay, right. So team celebration and reflection, let me logically complete this also. Okay, so conduct the final tollgate review, make the transition period. See, this is once you do the control phase, you need to conduct the meeting, celebrate, okay? Anything that is closing loose ends, address any remaining task or follow-up, recognize contribution of team people, jot down the lessons learned so that it is useful for the future, okay? And the team should brainstorm on new projects, fresh ideas, and then you need to make sure that this becomes a model for your project for the next projects, okay? So strengthens team moral engagement, ensures. These are all many words, so I don't want to read this, but I want to give you a final control toolkit checklist, okay? The team, all of you type CTC in the chat box, okay? All of you type CTC in the chat box. Very important for knowing this control toolkit checklist, okay? How well the new process is working, that must be measured, okay? Control plan should be made and shared with the process owners. And the team is set up the way to track the process so that it is within the desired limits. So the team actually gave the process owner or the business team all the tools and information to keep up the improvements in the same condition or improve it further, and sponsor champion leadership. Everybody knows about these improvements. The team had the meeting to review the projects and suggest ideas for future improvement. So that brings us the end of chapter 16. If you found today's session interesting, useful, valuable, fantastic, awesome, put it in the chat box.